Starting the recording. There we go. So, hello Zoomers, hello Roomers. Hello. Glad to see that Tuesday turned out to be a big pile of nothing, but I'd rather it be that way than the alternative. So I hope everyone is recovering from whatever happened last week and that we can maybe have some, I'm going to call it semi-nice days without tornadoes and maybe a little bit of sunshine. Dare to dream, right? So today we have a couple things, but the first thing is going to be Bladimir is going to present the work that he is going to show at NCME next week, and not just the presentation, but more of the behind-the-scenes look at how he came to get this process of going from an idea to analysis to presentation. So he is going to be taking my spot. He can take as much time as he wants. And after he's done, we'll see how much time is left to talk about homework, which is due Monday night, the Count Models Homework 4. I am in the middle of getting through your Homework 5 plans. I'm about halfway done, and I expect to finish that tomorrow. I will be returning those then. And then we'll talk about the remainder of Example 4B and quantile regression, time permitting. And whatever we don't finish today, we'll do on Tuesday. So come on up. All right, take it away.
Thank you. Okay, let me. I think that I will use the sheet. Okay. Hi, people in Zoom. People here. Thanks to be here. And as Lisa said,
Make sure your head's in the
should
camera.
I?
Yeah, you're taller than me.
Yes.
There you go.
And this is. Can you see the Word document, right? Yes, I can see like the green frame here.
Yep.
So they can look
Should be good.
Great. So today I will be talking about many things. But all of these things are related to what we did last year with this research project about how the Chilean admission system works, and I will try to explain you not only what we did, but some kind of decisions we made and some ideas that we had, and how we were able to translate those ideas into code in our studio and then into some modeling, analysis, interpretations. And at the end, I think that we are close to finish this thing because we have been working on this for the last year, but we don't have like the final version of the paper yet. So this is hard. It's a long-term thing, but I believe and I hope that some of the things that we discussed today here can help you to conduct your research and maybe work on your own research projects. I have 3 files that I want to share with you. First of all, this Word file. Here you will find like a step-by-step process about how did we conduct our research project. I work with Mubarak on this, and well, this took a lot of time, but here you will find like a summary. First of all, you will see that we work on the research question. Then we had to go to the data set, see what we had and how could we transform those variables, that information into something useful for our research question. Then I will talk a little bit about the analysis, how we adapt our results from numbers to plots to convey a clear message. Some of the things that we found could be some kind of challenge to analyze, and how we made some of the most important decisions to come out with the final model, which was a binary logistic regression model. Then about the discussion and a brief takeaway. Okay. Let me go. This is one of the files. Then this is the final thing that I will show you. This is the set of slides that we will be presenting at the NCME event with the summary of the things we did and the most important information to understand how we answered our research question. And of course, yes, happy face. let me. I would like to see the other file here. Yes, here it is. And I think that this is the most important thing because here I try to include all of those pieces of code or snippets that we used to analyze our data set and to run models and to conduct the analysis. And I think that this is the part that you can use if you are working right now with your data set and you don't have or you don't know how to manipulate your variables, how to transform them, or maybe how to fit the model, how to do this work, and maybe some parts of this document can help you with that part of the project. And feel free to use all of these things. And if you have more questions, of course, you can email me or you can ask me here. So I will start now formally with this document because first of all, when we had to work on this research project, I thought that maybe we could work with some things that I did in Chile because I've been working with educational issues in Chile over the last decade. So that's my field. I've worked on educational research in higher education maybe since 2015. I work on the Educational Research Center at at the Universidad of Bio Bio. That's my former university. I worked there many years. So when I have to work on research projects, my first idea always it is about the Chilean educational system, specifically the higher education system. And I wanted to work on something related to how the admission system worked, specifically for the last admission system that year, which was 2021. So, first of all, you can see here that in my case, in the Chilean case, we have two web page where we can get all the information related to to different aspects of the educational system, from primary and secondary and the higher education system itself. So these are the links. I don't know if I can see this here. Yes, it's working. Yes.
Did you let them in? Okay.
Yes.
I'm not in there, by the way, so if there's a chat.
So something really good about the Chilean educational system is that they have like an open access policy about almost all the information that they produce, especially from the Ministry of Education. So here you can see, well, this is in Spanish, but this is information about students. This is like kindergarten. Here you have information about teachers. This is for schools, and here you have information about people who support these schools. So if you want to download these data sets, you can click on these things and you will have access to a specific data sets with the information organized, I think, for years. Well, I think it's thinking. But here then you have like a specific aspect. So for example, if you want to do something related to the schools, you will have information about performance on the quality test, performance on different kind of measures related to quality, how they are working with the curriculum, how, well, many things related to schools, and then you have the information organized by year. So you can download that things and you will have the data set, which to me is one of the first things you must do. But at the same time, we thought about the research question because we had the data set. In this case, the information about how what the results of the 2021 admission process to selective higher education in Chile was. We had that information, that data set, but you have lots of variables, lots of things going on, so you don't know if the information you have is useful or not until you have a clear research question about what you need to know and what you want to answer. So for us, our first research question was this one, something very simple. We wanted to know, or we wanted to answer, if is there a significant relationship between socioeconomic factors and the probability of being admitted to selective higher education in Chile. That was the first thing. Now, this comes out trivial. However, based on this thing, we could figure out, for example, our dependent variable, which was the admission result. So at the end of the admission process in Chile, students, well, first of all, must take the admission test in mathematics, language, biology, physics, chemistry, and history. But four of them are alternatives. They are useful if students want to study something related to those alternative subjects, but there are two which are mandatory, mathematics and language. So we work with those two results, with admission test in math and language because they are mandatory, and we decided not to include the alternative ones because we had a lot of missing data. Now, based on this question too, we also knew that we could use, for example, these two kind of predictors in our model, which are the academic and non-academic, because our research question is trying to identify or quantify the relationship between socioeconomic factors and the probability of being admitted. Now, one of the assumptions of the admission system is that all the students have similar probabilities of being admitted to any of the selective programs in the higher education system. This is a selective process, of course, so they use ranks to select students. Of course, that, for example, if there are 60 vacancies, not all the students will be admitted. That's obvious. However, the admission system assumes that those probabilities are not conditioned on other factors except these academic factors, which are the results in the admission test and two other scores that are derived from the GPA from secondary education, which are called NEM and ranking. So at the end of this, like first process related to the research question, we also knew that we could be using binary logistic regression model because our dependent variable was a binary variable. So all of these things are tied to the research question. So once we had the research question, we knew what kind of variables we needed from the data set and what kind of analysis we could conduct using all of those things. Now, that's not all, of course. So then we had to go to the data set and see how to transform that information, which originally is organized in 4 data sets, because the admission process has 4 different stages. Students must take the test, they have the results, they must apply, and finally they have the result if they were admitted or not, and they can decide, for example, not to enroll or to enroll in the program they were selected. But we needed to clean that data, and we had to perform some data munging. Here is the definition from Wikipedia. So the HTML file that we uploaded with Lisa is the thing that we did for this specific stage. And as you can see here, this document is very long because we had to, first of all, for example, load the data sets. And that depends on the format the information was stored or saved. So in this case, these are spreadsheets. That's easy. But if you have other kind of formats, you will have to use the different commands or functions in R. Now, I will explain this file a little bit now, but again, first, I would like to say thank you to who create this command, the pipe command, because you will see that we use this a lot. Basically, with this thing, what you are saying is like take the thing before, and with the result of that, do this other thing after doing that. And it seems simple, but if you don't use the pipe command, you will have to do this thing step by step in RStudio, and sometimes that's tedious. So you will see that using the pipe command, we can like summarize some of the functions, and this helps a lot. So thanks to that person.
Bladimir, where did you learn about pipe and how to do this?
About this thing, yeah.
Learn how to munge.
Yes, all, well, most of the things that I will talk about right now comes from this course. I learned how to do this here in the MS program, specifically with Professor Brandon Labo in computer packages course. That was last year, and he has some units, very useful. So here are the links. Here is the links, I think, to the, yes, this is the repository. So here you have the RMD files, which are the R Markdown files. You can download these things and look for the information you need. But well, I learned all of these things thanks to Brandon.
6250, by the way, is the class number.
Yes, and now I think it is, yes, right. So this is open access. You can consult these documents. You can take the things you need, and of course, when we had problems, you can use Google. Most of the answers are there. So I'm very glad to how our studio works and how the community help to each other to solve basic problems. Now, data munging process. Once we have the data sets, please don't consider that coding. I'm a lazy coder, so I tend to use just one word to define things. I use A, B, or C because that's the way I work. My more complex work is A1, A2, A3 when I need to organize more things, or just use, for example, data. You will see that I'm storing all of these things at the end in something called data, which is like the data frame that I will be using for the analysis. The problem with that is when you work with multiple things at the same time in RStudio with the same name, RStudio doesn't know that, for example, if you have two syntaxes in parallel, it doesn't consider that maybe the object with the same name is different based on the syntax you are using. No, will be used the same object created. So my advice is please pay attention to these things. Don't use these kind of things. I do it, but then I have problems. So this is the pipe command that I talked earlier, and the thing here is I'm talking with R here, and I'm saying, please R, take this object, which is the information that I have in the registration process, because here I have all the information about where the student studied, some of the information about the school that he or she graduated, and I have some of the results for the admission test. What is the score for maths, language, the alternative things, what are the number of questions that he or she got correct, lot of information. But here I don't need all of those things. I only need the student ID, the sex, this is the school ID, this is the type of, one of the characteristics of the school, that's other school characteristic, this is the sector. Well, this is in Spanish, but then I translated these things into English. But this, for example, is the sector public or private subsidized. So once I have all of these things with the verb select, this function comes from deep layer. So this package in R is the thing that I always use, and most of the things that we do in classes with Lisa, I use deep layer. But the problem is that if you don't load the package later, you cannot use the functions inside. So this specific part here is saying don't load deep layer, but if you have this package installed in your R desktop, you can look for this specific command within this package without loading that package. So take these variables, and then again, once you have that variables, do this. Apply a filter. And this is one of the decisions we made, which was important. In that line, I'm saying, we are saying, there are many students here. We had something like 200,000 students, lot of students. However, some of them had characteristics that we didn't want to include in our studies. So we want to work with students who this is their first process, because in the admission process can participate students from previous ages, of course, not only people who graduated the same year, but we were not sure if our results could be generalizable for that kind of people. So here we are trying to create a profile of a student. First of all, so please, I want those students who this 2021 is their first admission process, and we also want to work with the students who were exposed or who learned with the general curriculum for secondary education in Chile. In Chile, we have many types of curriculum for secondary education institutions. There are some for orals, some like for special education, but we wanted to work with the students who learn from the general curriculum. Why? Because the admission tests are designed based on that curriculum. So it can be hard to analyze the results of some students who learn with a different type of curriculum and had, for example, low scores or low performance in the admission test. Well, that's expected because they didn't learn with the curriculum used to design those tests. Then again, more filters. Well, no. This is more select, because then I want to use a set of variables or set of columns from my data set. Mutate, this is another useful thing because here I'm creating these new variables, as I told you before. Here we have gender, so if else, for example, code sex equals 2, we know that those students are women, so give me 1. And otherwise, give me 0, and so on. Here you have the type of high school, and here you have the dummy codification for sector. Now, the coding scheme, that depends on the kind of questions you have. Here, we have this nominal variable, so the dummy codification was the obvious option, but you can use sequential coding, Helmer coding, or effect coding. That depends on your research question. Finally, please create this, select this final set of variables. So all of those things that I described, thanks to the pipe command, are stored in this A frame, data frame. And we did the same. You can see a lot of code here, especially when you have variables with many categories. For example, that's education, mom's education. Here we have 13 categories originally. So we had to read what the meaning of the label was and then decide what kind of labels we wanted. So for example, this part here is saying for people with education between 0 and 5, which is like no education, basic education complete, basic education incomplete, some primary instruction, all of those people, please just create one category, which is basic education. Now, if you are interested in more precision, you could use maybe another kind of categories, but that depends again on your research question. For us, was enough to have this kind of variables. At the end, please, if you have questions about this, raise your hand or just ask, please, because maybe this can be difficult. So now, using this other function from the package cable extra, I think, we can take our data. This is the data frame with all the information we selected across the 4 stages. We created this table. This is to explore the data set, and then we can see if the things we did work as expected or not. So first of all, you can see the GPA, which is the GPA of the student across the 4 years of secondary education. In Chile, we use a scale between 1 and 7, but most of the students have grades between 5 and 6.5. So this is the grade. This is the standardized score really, associated to this GPA. This is a linear transformation. Now, this ranking, this is similar. I think that I could talk, yes, like 2 hours about the just ranking, because this is something really important for us in Chile, because back in 2013 there was a discussion in Chile about how to compensate for the educational differences between students, especially because students who attended private schools, they had more chances to be selected in the selective programs compared to students who attended public schools, and they wanted to correct this kind of bias, and one of the alternatives was ranking. What is ranking? So it is again a standardized score that reflects what is the position of the student in this school with the GPA he or she got. It is like a standardized score for the position or rank that student got in the school he or she attended. So it tries to compensate for the differences across schools, considering the context, the educational context where the student studied. But well, you can see that most of the time ranking is higher than NEM, because how the admission system works. At the end, the students have a composite score. I've not talked about that, but that's very important, because the composite score is the thing that the students at the end have to apply for these selective programs. And that composite score, it is a weighted combination of the scores in NEM, ranking, language, math, and the alternative exams that you had to take to apply for a specific program. So ranking, as you can see, most of the time is higher than NEM, and is trying to increase the composite score of students. The other set of variables, here is admission. This is our dependent variable, binary zeros and ones. So we are ready to create the code book. This is very easy if you use, in this case, again, the cable function. You can write the things that you want to show, and at the end you have this nice table, I think. So we have the name of the variable. Most of these things then will be the predictors we will be using, a description, and type. So this is like the structure of our analysis, the materials we will be using to work with. Then a sample description. Here you can see some descriptives. And now, yeah.
So about the ranking variable, so does that mean the higher ranking means higher position?
Yes, exactly. Should be. Yeah, because the problem here, or the problem, let's say back in 2013, it is the problem, yeah. Ranking didn't work as people expected and foreshadowing some limitations. But as you said, the idea was that, for example, what happened what happens if we have two students, one of them has a GPA of 6, the other has a GPA of 5. Well, based on NEM, and I will show you this with one, I think that we can use one of these rows. This thing here. So if if we compare, for example, these two students in terms of NEM, we could say that, of course, these students had a higher GPA, so he or she deserves a higher score in NEM, right? However, we do not know if this student attended, for example, a private school or a private subsidized school, and his or her educational context was better compared to this student. So let's assume that this student attended a very good school in terms of quality, environment, safety, compared to this student who attended a public school with many problems besides the educational thing. Because in Chile, there are many public schools that must, for example, be worried about violence, about some kind of abuses between children. So they cannot be focused solely on the educational part of their tasks. So let's assume private school versus public school. So it is not fair, people think, and I think, that these students with different GPAs should be considered as the same student with the same chance, or with the same kind of or type of experiences. So what ranking tries to do then, it is, for example, okay, this GPA is lower, but maybe in the school that this student studied, that is a good GPA. Maybe that's like an outstanding GPA. So if this student has outstanding GPA compared to their peers, this will be a higher ranking compared to this other student.
So like if they're first in their class, even though their GPA is lower, then they're a good student.
Exactly. And that's the idea here. How to identify good students. That's the idea behind the ranking. Well, this didn't work. Uh, and you can see that most of the time students with a high name have also a higher ranking, and you can see that these differences between students based on type of school are consistent with the scenario that we had back in 2010, 2011, 2012, when we had this discussion in Chile. But the idea is that how to identify good students. So thank you. And this was a big problem that we found. Why? Because at the beginning we had this sample size. These were all the students that we had in the raw data set. Then we performed the data munging thing to select some of those students based on the type of students we wanted to analyze, related to the research question always. And we were working with this sample size. Students taking the PSU test. PSU, it is the exam admission, the exam test. Students taking the exam test and who learn from the regular curriculum. Everything was going well. However, when we fitted our binary regression logistic model, the binary model, we had a probability of being admitted equal to 0.01, I think. 0.01 or 0.02. So we thought that maybe we were estimating thresholds instead of intercepts. Yeah, true story. Because we said, how can be the probability of being admitted too low?
So 1% of the sample got admitted, is what
Yes,
the results indicated?
something like that, exactly. That was crazy. So my first idea was something like, oh, maybe this is estimating the thresholds. Like, no, but then we realized, as you can see here, that there is another thing that we didn't include, which is some students decide not to apply based on their results. So we were including those students in the model, and of course, the probability of not being admitted was overestimated without reason. So we had to go back and, well, this was for the part where we fitted the regression model, but you will see that for the plots we have with the means that I will show you now, that sample size is based on these people because they took the test but they didn't decide to apply. So that's the filter. That's the extra thing that we didn't include at the beginning and we had to include later. But well, so yes, this was our sample size for the regression model.
Of relevant people, because they could have been admitted.
Yes,
Decided to apply.
yes, exactly. And that's one of the things I think that Erika is working on that. Yes, yeah, because as Lisa said, the thing here is not the score, I think, or maybe cannot be the score, but we don't know. So it would be helpful now to go back one step and try to fit a model to explore and analyze how these students who didn't apply are related to the variables or predictors we have in this data set. Because maybe there are not only differences in the probability of being admitted based on the socioeconomic attributes, but also in the probability of apply. So yeah, that will be a, yes, that's the Erika's word, right? Work.
And I'd like to point out that we're not even to your model yet. Right? So this is all the work that goes into real data analysis before you can even do the thing you wanted to do. In my experience, is 80% of your work will be in this stage.
Yeah.
Then the model is like the very, very last final thing you get to do.
Mm-hmm.
So as a heads up for homework 5, and anytime you're faced with real data are messy. I try to spare you from that with my homework, with the canned data that's nice and organized and complete, but that is not the world. So, and working with public use data, I imagine, is even more challenging.
Yeah, that's not even close to the ideal scenario. Well, and I've not talked about missing data yet. Why? Because I don't want to. uh, there are many decisions to make based to how to treat those cases, and most of the time, well, what we did here was to explore those missing data, try to first of all see if based on the labels that this data had, we could decide, for example, okay, let's say that the label 13 is for people who didn't take the test or for people who have results from previous admission processes. So let's drop that people. The thing is, when you have some values that you cannot infer or you cannot decide if they are wrong data or maybe just there are some problems with the labels. Well, I think that's hard to how to treat missing data, but here based on these filters that I showed you before, based only in these two characteristics, you can see that we dropped how much, like 50,000 students immediately, just based on those two things. So then this was worse here because at the end we were working with less than the half. Yes, this is like a third maybe of the original sample size. That's well, that's like a trade-off in between what's your research question and what are the characteristics of your data set and how can you analyze this thing. Now, this is a good table, and yes, Lisa was right. Now we are talking about some things more close to the analysis that we conducted. All of the previous steps were data munging and exploring and first analysis, but this is like the first thing we analyzed. Of course, here you can see a lot of numbers, right? I think that tables are quite good when you want to summarize things, but I think that most of the time they are not clear to convey some messages. So I included this table here because this was our original idea, but then based on some recommendations, we decided to transform these tables into graphs, and I will show you those graphs too. But this is the information that we were interested in. These are the means. All of these academic factors have the same scale between 150 up to 850. So that was not a problem for us, like to create a common scale, because the admission process has a common scale for all the admission factors. Here you have the means and standard deviations for some specific characteristics we were interested in. In this case, gender. Well, this was sex. Type of high school, humanist and technical. I don't know if here you have this division, but in Chile, secondary institutions can be humanist or technical oriented. What is humanist? Basically, in secondary, you will have biology, physics, and chemistry as part of the secondary curriculum. If you decide to go to a technical school, you will have some kind of professional training in accountability, management, and other things more focused on the field work or how to work on something after the secondary education. But these schools are more focused on how to prepare you for higher education. So maybe this can be another kind of filter that we could apply. Why? Again, because these schools, these institutions have a shortened version of the general curriculum. The students here learn from the general curriculum. However, there are some contents that they didn't see because they were not relevant for them to work. Maybe here there is another thing to see. Okay, that's a typo.
You only see the typos when you're presenting.
Yeah, yeah. Yeah, why? Because this is a family income quantile family income. But here you can see it says income, but then we have tertiary education, but that is from educational level of parents. Yeah, sorry for that, but I think that you can catch the main idea. And this is the code if you want to replicate this kind of things. First part of the analysis, well, this table, yes, pretty good. However, let me understand this thing. You can see here that we have the four admission factors we were interested in: the mathematics score, language score, ranking, and NEM scores. And this, I think that I forgot the labels, but here it is. Mother's educational level. This is a variable that we wanted to include in the model because if you talk about education and socioeconomic background, you will have parents' education, family income level, maybe, I think that those are the two more important variables. Maybe sex or gender, the type of school, of course, yeah, but that's not related to the family itself. Well, you can include it in a multi-level analysis, but I will talk about that later. Now, what you can see here, differences. We expected these differences based on the literature, yes. There is a lot of research in Chile that says that different kind of socioeconomic backgrounds translate into different levels of performance in the admission process, and that at this level correlation means is true, but these are only average scores, so we are not doing nothing else than compute means and compare. So this is not inferential analysis yet. What about family income? Same thing. You can see that as the family income quantile increases, the means do the same, even in ranking. So I think that that's something that we don't like to see. Or this is like the scenario we wanted to avoid some years ago. Because here you can see that ranking, it seems to be correlated or associated with the family income. The same, well, this is more attenuated, I think. This is more similar, yeah. What time is? Okay. Yes. Yes, okay. Finally, the binary logistic regression. And here you have all the code that we used. We had to fit 3 models. We performed some likelihood ratio tests to decide what set of predictors was better. And at the end, this is our final version. Okay? You can see, well, this label means that we centered our quantitative predictors at 550. But then we reconverted the scale. Basically now this is, instead of 150 to 850, from 15 to 85. And then we centered that new scale at 55. Just for convenience, because these coefficients were pretty small, like a 0.0000. So that wasn't useful. We had gender, quintile family income, and the type of sector for the school. Those were like the significant things. However, in terms of surrogate R-square, this set of predictors explain just 10% of the variance in our outcome for that 90,000 students that we had. So that's lower than I wanted, but at the same time, this is a finding because the papers that I've read related to this thing, they are focused on this part, bivariate relationships. So we have a lot of evidence about how the socioeconomic background of students is related to performance, but I think that, or I've not read yet, papers talking about specifically the admission result. So then I thought that maybe this can be a finding too, that I could highlight later. Well, a table, because again, numbers are numbers, but we think that a picture would be better. This should be wider. These are the odds ratios. So you can see that here, sector private is like the most relevant predictor, positive predictor, and maybe maths. Lots of linear combinations. Yeah. Yeah, but for transparency, for sake of transparency, we perform like how much? Well, how many? Like 30 linear combinations just to get this thing, which are the estimated probabilities of being admitted, conditional on those different characteristics, which are the significant predictors for our model. So here you can see these numbers, but again, maybe it's hard to think about the effect of these things with these numbers. So I think that yes, we created one figure more, and here I think it's clear. This is the end. This is like the answer for our research question. So back to the research question. Are the socioeconomic characteristics important in the admission process in Chile? Yes. Yes, they are. And they have some kind of impact in the probability of being admitted, regardless of the assumption that the admission depends solely on the academic factors. End of the story. That's all.
Also, it's bad to be a girl.
Yes. Yes, it is. And also, yeah, because these are females. These are type school sector. This is a school sector. Blue private, red private subsidized, public. Greens are public. I attended public schools, and I can say it's hard. Yes, it's hard, but well, I think that there are many things to do in Chile. Now, a key difference I think between Chilean research and the rest of research in other countries, now as authors we would propose some kind of policy of correction to the policies that we have in Chile in higher education. I don't know why, but at the end of each paper we have like a 3 or 4 paragraphs where we discuss how to correct this or how to apply this thing into policies, something that now I think it doesn't matter because those are just words. I mean, this is specifically related to our research question, to the decisions we made. I think that these kind of results are just like pieces that we can use for something, but I think that we shouldn't base some kind of decisions just on this type of evidence. So this is the end. I lied. Well, yes, yeah, yeah. Why? Because even when here you can see that, for example, students who attended private schools, it seems that there are differences between quantile. Then we wanted to see, just based on one of those attributes, what was the distribution of the probabilities. So here you can see that for students who attended private schools, the probability of being admitted was higher compared to the other two schools, especially above 0.8. So that's a very, very high probability of being admitted. Exactly. Yes. Exactly. Yeah. Now, yes, I explained that. Discussion and conclusion. Yeah. Then we just analyze the things that we found. So the NCME slides, I think that they have the same information, but yeah, because I have like 3 minutes to go over all of these things in the NCME event. So I will be like, hey, my name is Geraldo. This was the research question we had, and this is the outcome, and that will be all. Conclusion, straightforward, but yes, exactly, yeah. So this is like the final summary. Here you have the research question, then description of the method that I described, the same plots that you saw. This is just like to see what the general scenario was. The estimates, but again, I think that I removed this part in the final set of slides because maybe numbers are not very useful, but these things are useful because here you have the academic and non-academic factors, significant factors, and you have the odds ratio. So you can compare the effect size between these predictors, and you can see that as the research, as the literature have showed, this characteristics is very strong if we talk about the probability of being admitted. This thing is weird.
So keep in mind the difference in scale, right? So these are all slopes.
Yes.
It's a 1 unit change.
Mm.
1 unit on the left-hand side is an increase of 10 points. 1
Exactly.
unit on the other side is going from like public to private.
Yes.
So they're not really on a comparable scale in terms of that. I
Yeah.
think you could compare variables that are of the same kind, like the the ones all on the left I think are comparable. The ones on the right that are just characteristics that you turn on and off might be comparable.
Yes.
But it's hard to go back and forth.
I will rephrase myself. This shouldn't be the case. That works? This shouldn't be here. That's all what I want to say about this. Why? Because students shouldn't have different probabilities of being admitted based on the school they attended, because the educational system work as a whole. That's one of the conclusions we have, and this is a challenge for the admission process, because the admission process has many assumptions, and one of the most important assumption is that at baseline or on expectation, if all students learn from the same thing, and if use that thing to design the test, so we assume or we expect all students having similar scores on those tests and similar probabilities of being admitted to selective programs. So this shouldn't be here.
And that's the difference after controlling for the test scores that are supposed to matter, right?
Yeah.
Like I think that's the critical thing. It's like, well, maybe the kids who went to private school had better test scores, but that's irrelevant because this is after controlling for that.
Yes, that's the second thing to consider. So I will summarize Lisa's comments for people in Zoom. First of all, the scales thing are not very comparable, because in this case this is a categorical predictor. So going from 0 to 1 here is like going from a school without students in private versus schools with students in private schools. And the other thing is this effect here is the unique effect of this variable after controlling for all the things in the model. So yeah, that thing, the conclusion, and that's all. I think that I didn't miss anything. I covered that. The takeaway, so yes, I was forgetting that. Yes. Research question, that's the heart of all of these things. Questions?
No question, but thanks
Great.
for sharing, because it's nice to see the processes of things. Like, we see the finished product of stuff all the time. It looks so nice, and we're like, oh, I'm working with this pile of garbage. How am I going to get that? But
Yes.
it's good to like be able to see how that works.
Yeah, it is
Thanks for
tedious.
sharing what that looked like for you.
Yeah, sometimes it's tedious. It's like a nightmare.
How many months have you been working on this?
Sorry?
How many months have you been working on this, or years?
We started, I think, spring last year. April last year. Okay, April, and we are in May. April, so 1 year. Yeah, 12 months, 56 weeks.
Do you have an hour count for us? Or
No, no, but at the end, I think that I've talked about this specific research project so many times that I'm starting to feel tired of this thing. I want to move on, but right now I will take 1 minute, because now I've not talked about the limitations of these things. There are many limitations. One of them is what Erika is trying to do right now, which is related to this plot. What happened with these people who decide and don't decide to apply? That's important. The other thing is, I told you that the students attended schools. What do you think if I say students attended different type of schools? Some kind of idea? We have students who graduated from the same school, and we have like 1,000 schools. What could be a potential problem there? What we are assuming, yeah. First of all, here we are assuming what? Independence between observations. However, we have students graduated from the same school, and we have a school ID. So one of the limitations here is that we didn't consider that nested structure. And that's what I would like to do now, and in fact, this summer, I work on a cluster multi-level model, but that model is only related to the results in the math exam. Basically, I use the same variables to see how they affected the performance level in the math test, considering the nested structure. So we have predictors at level 1 and level 2, and we can do the same with the language exam. That's one thing. And the other is the path analysis project that I hope to show you if we have time. Because we have here only one outcome, admission. However, we could try to explore the relationships between the socioeconomic factors with the academic factors with some of these results. So that will be complex analysis, but it will help help me to isolate the effects of the different things that we have included in this model. So this is the first step, and I hope to show you next steps and next results. So thank you. Yep.
Yeah, so you can present in every class I teach. Just keep adding layers to this, right? Yes. So, hey, Zoomers. We've got about, let's see, 10 minutes left. I wanted to make sure that we could talk about homework. Does anyone have homework questions? The homework that's due Monday, by the way, just to clarify. Yes, want to ask?
Yeah, I was wondering, so for the new predictor variables we have to make, so the one where we have to create a predictor for number of food school sessions.
Yes.
I guess like I'm just trying to figure out like what it should sort of look like in terms of like, because I know you said to reference slide 15 from lecture 1.
Yes, I did. Should I pull that up?
Yeah, that would be helpful.
I would love to. I tried to be as specific as possible. Yeah, and I put this here knowing that this was coming, by the way. So yes, this is an example where the count is number of cigarettes, so this is what like your original variable would look like, yeah. And you need to turn it into something that looks like this.
Right. So like, so the maximum number of sessions, just because I was looking at the data set, is that different for everyone, or is it like up to 6 for everyone?
It's different for everyone.
Okay.
Yep. So the code would have to work with this sort of like if it's greater than, like for instance, like if the number is greater than, then
I see.
Yeah. So like the key here, I think it's easiest to see it in the Stata version here. Cigarettes minus 1 covers every possibility, no matter how far you go. So I would do it that way rather than saying if 2, then this, if 3, then this. Yeah, I mean that would work. It would just be more work. So yeah, but this is what it needs to look like. So then you have one variable that says did they participate at all, and then if so, which is applicable only within the people who participated, how much? Mm-hmm. Yep. Sure.
I have questions, but it's like hard to ask right now because a confusion I had in the interpretation part.
Okay.
Could I talk to you after?
Yeah, that would be fine. Other questions? No? Not even on the interaction terms? Those ones are a little bit tricky. But the key idea is to recognize first what is the slope that the question is asking about. Don't get distracted by the end of the sentence. That is who the slope is for. So like what is the difference in predicted number of foods between children whose parents do not versus do work full-time? Like all of that means the slope of full-time. And then who do you want the slope of full-time for? A kid who went to food school 1 time or something like that. And so the rule for those is the same as what we've seen throughout the semester. Step 1, figure out what the slope is that you're asking for. Step 2, find it in all the terms. and bring those down. Factor out the slope as step 3, and then what's left is how you make the sentence. So for instance, if I'm estimating what is the effect of full-time work, and that's the thing I care about, every term that would be turned on in the ones and zeros in R or be attached to a number in SAS or Stata needs to have full-time work in it. And if it doesn't belong in it. That's where I've seen people get messed up, is they try to put in the main effect of food school sessions thinking, well, it needs to be for a kid with 1, but no, that's the moderator. It would be food school times full-time work is how we would turn on the moderation for that. So it's exactly the same as we've done throughout the semester, despite the fact that it's a count model, because linear models don't care. The linear predictor works the same way regardless of what the outcome is. So that's the one catch that I've helped people with so far in that. So no homework questions? Couple things that have come up with respect to the homework 5 plans that I've read thus far. So what is happening is that I'm giving you comments and feedback, and if I'm happy with what you've done, and I just have a couple suggestions, I say 2 points, go forth and model. There's a few folks so far to where I feel like we need to have a bit more conversation because either you planned too much or what you planned isn't going to work necessarily. And so for those people, I gave you 1 point and said, please come talk to me or send it back so that I can make sure that we're both in agreement on what you're planning to do. In the instructions, I had said that I am allowing you to ignore additional layers of complexity that we didn't address. So for instance, Bladimir ignored school dependency. Now, if you were to publish this, Bladimir, you are probably going to get reviewer 3 to be mad at you about that, and reviewer 3 has a good point. So like if this were just a class assignment, I'd be like, sure, you can ignore that because we didn't talk about it. But for those of you who are actually trying to publish your work, I want you to think about it from that angle, like what would be a compromise that would be something that would be acceptable. So for instance, if you're interested, say, in school and children outcomes, and you are interested in, say, like percent proficient or something like that as a function of school characteristics, it would be more correct to aggregate across the children and just do a school level analysis than it would be to ignore school dependency. Because the interest is at the school level, it would make sense to collapse the data to just focus on that, to make it a single level model. If you're doing longitudinal data, it might work just to use like the first occasion or something like that, or to select occasions such that there's not redundancy, not multiple occasions per person. So I have comments in there about like, it's okay to ignore this for my class, but I just want to be aware that it's not okay to ignore it forever. But I'm also very realistic about like, I can't ask you to do a clustered multi-level generalized model if we didn't talk about that. So I will be getting your feedback on those, and if you have any questions, please let me know. Then otherwise, you have a formative assessment is the next thing, and then homework 5 is due in like 2 weeks, 2.5 weeks. So plenty of time to work on it. All right. Any other questions or things you want to talk about while we have a few minutes left? No. Okay. How about we save the rest of the stuff for next time? Sound good? All right. Let me know if you need anything. Office hours on Monday for last minute homework questions. Have good weekends. Thanks for being here. Bye, Zoomers.